So I start. Good afternoon, everybody. I'm Swann from EPIA, and today I will present LusTra project. LusTra means Ludique trash. I will present the context and the objectives, the gamification part, the machine learning part, then the result, and I will conclude. In Switzerland, the recycling rate has reached a plateau, and the incorrect sorting waste is a real scourge. Sorting waste doesn't seem to be instinctive, and sorting errors cost to municipalities. Our proposal is to build an educational tool as a sorting game, mainly for primary school, as well as developing a logistic tool for the manager. Our objectives are to motivate. Our objectives are to create a motivating and playful sorting system for young public, to make them responsible for their sorting behavior and right gesture. Our system is an interactive, incentive, and rewarding gamification system. We want a trash that automatically recognizes the type of waste that is thrown into the bin with a machine learning model trained on real sensor data. We are currently working on pet recognition, metal recognition, and glass recognition. Here is your gamification prototype that you can see at the demo stand. Here is the trash prototype as an embedded system composed of a Raspberry Pi that executes the waste classification application from images captured by a Pi camera. Since the trash is dark, the light source is added. We also used TensorFlow and Keras library for the machine learning part, and we trained our model with NVIDIA GPU. The trash bin and the game platform are connected. When the child throws a waste into the bin, this launches the game as a fortune wheel. The game rewards the child in case of correct sorting. Then the child continues to play with the virtual sorting game to learn how to correctly put the waste at the good location. The pedagogy aspect mainly focus first to the playful aspect to motivate the child to take part of the waste sorting. Second, the educational aspect to teach the child for his sorting behavior and have a reflex to eco gesture. Third, provide the feedback to the child, the teacher, and the manager without discriminating the child against his sorting behavior. Here is the embedded application execution flow. First, we load the TensorFlow library. Then we start recording the video. Then we search to detect a moving object. If there are a moving object, we take a picture of the object. We classify the image with the machine learning model. Then we send the image to the server, and we come back to the detecting moving object, etc. Here is an example of the output of the classification. Here we have the machine learning algorithm used, the classification, and the probabilities. We recorded 200 of pet images and 200 of other waste images. Here is an image sample. The classification result of 7 machine learning models show that we have more than 90% of success rate for pet versus others category. The errors mainly come from bad discrimination between class and pet bottles. As you can see, in these error images, we have a majority of bottles. And I will introduce. This is David Gonzalez. It will present the game interface.
Here you have a video of the first the first prototype of the game, the graphical game for the child. Here we can see. Here we can see the home screen of the interface. You see after trash, it is rainy, it is windy, it is not very nice come like the waiter. So when the child put a trash in the trash bin, it will send a signal to the application, to the game. It will send a signal to the game, and then he will have a feedback of his put-in, and win a trophy if he has done correctly. Here we have all the trophy has won as far, and then you can play a virtual game where even if he has wrong, he can do retry until he does good correctly. Here we have the wheel to gain the trophy. And then at the end, you see the waiter has improved so that the child have a visual feedback of his sorting. It has impact on the world he lives in. At the end, we have this nice animation, the blooms, the nice flower, to show the child how the world is beautiful without pollution. My colleague will then conclude.
LusTra can be extended to 4 types of waste, with mainly focus on pet category. We can improve the camera with infrared light and add other identification techniques. We will build a fully integrated device, and also we need to work with pedagogy experts and design specialists. Thank you.
Congratulations, it's really a fascinating project, and we can see now Geneva beans tomorrow, your system just telling people who put whatever in the bin just to tell them what they could maybe put it elsewhere or somewhere else. So there's plenty of opportunities for the future use of this, this idea. It's really brilliant. So I don't know if there are any questions.
Hello, and thank you for the presentation. I just had a question on the feedbacks, the positive feedbacks, trophies, etc. And in general, for serious games, I'm not sure we think enough about the positive feedbacks we're giving. In this case, it's a nicer weather, which is a sunny weather, maybe providing some desertification and nice cars, etc. While it's actually a game about sustainability. So I'm just curious about whether you've thought of the positive feedbacks you're providing, are they linked to the theme or just shiny big cars?
It is, for the moment, really, it is random, I say it, because we have not, we have not already asked experts on this matter. It is a next step for the project. So it will come, but at the first prototype we have here, it is for now like this.
Thank you.
Thank you.
Any other question?
Yeah, I have a question. I didn't get, I didn't understand exactly what is the deployment scenario. Is it dedicated to be used within in a best scenario? I don't know. I'm not speaking for tomorrow, but the best scenario will be to deploy that in the city and having a feedback through an application, or is it intended to be used in schools or something like that? What is the usage scenario?
We will deploy it in schools and also in festivals and events. It's the main goal is to
The main goal of the project is to educate. So we put it in special events in partnership with schools, partnership with schools and other association company.
Thank you. Nice.
Okay, last technical question. Usually when you use artificial intelligence, particularly if you use images, you need many images to improve the precision of the tool. And here with 200, you had a precision, what you call effectiveness of 90.1%. So it's quite impressive. How did you manage to get that number with 200 bottles?
Il te demande en fait combien de le pourcentage.
Oui.
Il est très élevé et du coup il te demande comment tu as fait pour ça.
I used convolutional neuronal networks models for training, and I tested 7 types of models already developed by Google, Microsoft, or other, and I used machine learning techniques to improve to a maximum the performance. The machine learning techniques are normalization of data, data augmentation, transfer learning, and a step of post-processing to change the decision threshold of the neurons.
Swann, excuse me. Perhaps precision. The question is more about how did you get high precision with few training data? Is it normal or not? I think this was the question.
This was the question,
Yeah.
yes.
Is it normal to get 90% of precision with only 200 objects?
After augmentation of the data, I have more than 1,000 of images in the data set.
Explique les modifications que tu as faites.
The data augmentation step is to take one image and apply rotation, zoom, translation to duplicate one image to many images.
Okay, that makes sense then. Thank you.
Okay.
At the beginning, maybe he didn't understand the question, but what he did, this is actually what he just answered. He got these 200 images step by step. It was in the scope of his master's thesis, and also for David, it was master's work as assistant in our labs. Actually, he spent many times, this is what you said, he spent many times to get these 200 images from real cases that he put in the trash. Then he used well-known artificial intelligence techniques to augment and to get more images from the beginning, because we know that the learning stage is really important. And the next step is to make the manager to discriminate between the false positive and the false negative, to resend another training stage so that we get more precision, better quality in the system. This is what we try to do now. Thank you.
Yes,
Very brain tidy.
The images don't come from internet.
Okay, so.
The data is self-made. You made your own data. Okay,
Yes.
nice.
Excellent, and we look forward to see the project tomorrow in Geneva. Congratulations. Okay, thank you.
Thank you.